So hello everybody, my name is Łukasz and I would like to welcome you to my today's talk. So today we're gonna discuss how to create your very own Google Meets clone. So simply what I'm gonna do, I will try to live code a custom video conference room with the use of the Membrane framework, which is a tool to which I have slightly contributed. And it's meant to be used for multimedia processing. Okay, so let's start with actually describing the goal. So what do we want to achieve? As I said before, we want to have a video conference room. So probably it will be better for all of us if I simply show such a room. So I will try to show you the expected result. So we want to have some kind of web application, and we want to have a place where we can put the room's name as well as our display name, and we want to join to this room. That's the first thing. However, we want to communicate with other people, so we also want somebody else to join that room. And as you can see, we can see each other, and we could and we possibly could talk, but probably there's no point in talking to myself, so I will just leave it for a moment. And let's go back to the presentation. So to summarize, we want to have a browser application which will be capable of sending user media to the server and receiving that media from the server and displaying that media, of course. By media, I mean video and audio. And of course, the server, whose responsibility will be to relay that media among the browsers. So one might wonder why, well, it's actually what Google Meets does. So why not to simply use Google Meets? Well, because Google Meets is not customizable. And our solution, based on the Membrane framework, will be customizable. Or I hope so, at least. So now, before going to the coding part, maybe let's try to think about the architecture of our system. So as I said before, we're going to have two parts, the client and the server part. And the whole business logic here will be put in those two red boxes, which are like the room object of the client and the room process on the server side. And another thing which is worth noticing here is that we are having two communication channels. The first one, put on top, is the signaling channel. It's based on some TCP protocol, and it's meant to send some controlling messages. So for instance, once some client joins the server, server might want to broadcast such a controlling message to all other clients who are already in that room, but the new peer has connected. Another communication channel is the one visible on the bottom. So we have like some kind of UDP or generally datagram based communication there. And those two blue objects, which are like Membrane WebRTC and RTC engine, are communicating like without anything in between using that channel, and they are exchanging the media, so video and audio, like basically. And when it comes to the behavior of that system, we need to, Membrane WebRTC needs all to communicate with RTC engine also using that signaling channel. And we need to somehow pack these controlling messages or so-called media events, as we will refer to it later, and transmit them via that channel. So once there is such a media event, our room process, our room object here and the room process here will need to transport them via that channel. Okay, and now let's focus on this part on the server, which can be considered the heart of the server, which is the RTC engine. So let's get back here for a moment. So it's this part. What is the reason why do we have this part? Well, it's the the element which will be displaying that media among the browsers. So as you can see, each browser has a corresponding endpoint. And that endpoint is responsible for getting the media from the browser and sending media to the browser. And what is important, these endpoints are also talking with each other, as you can see. And they work in somehow, we can call it the subscribe, publish and subscribe mode. So once the endpoint is capable of sending some media, it publishes some media track. And other endpoints can simply subscribe to this track and start receiving data from the endpoint. But the question in the subtitle is what makes it so modular? Because in the membrane framework, referred to the architecture of the RTC engine as the modular RTC engine. Well, basically, it means that we can create our own modules, our own endpoints, as you can see in the picture on the scheme right now. So, for instance, we can create our custom endpoints, just like this HLS endpoint, which will subscribe to all tracks from other endpoints, perform some business logic, in that case, creating the HLS stream, which can be, for instance, stored on the disk later on. So this is the point where we can add our own custom business logic to that module. Okay, so right now we have discussed a little bit about the architecture, and let's go to the coding part. Since I still have an instance of the video room running, so I will kill it and try to check out to the branch on which we have prepared some kind of template. Okay, and since the whole video room application is generally a Phoenix application, so we'll simply run it just as a regular Phoenix application. And now, as I said before, we are on this template. So it means that most of this boilerplate code is covered and already implemented. However, the most crucial parts of the system are not implemented, and we will implement them in a moment. Let's see how the things look right now. So what happens in case we connect to the room right now with this most important parts missing. So the first one connected, we can see that we can see ourselves, but once the other peer tries to join, they cannot see each other. So that's not the point, and we have to somehow repair it, and we'll do in a moment. Okay. So as I said before, our application has basically two parts. And we'll start with the front end part. So we will implement the room class, which was shown on the scheme. There is a little bit of code already here. So generally, we have some fields and partially implemented constructor. And for instance, what we already have here is that we are creating a socket, this one which was meant to allow us the signaling communication. So we are creating it, connecting it, as well as creating a WebRTC channel via which we will send the signaling messages. However, we also need to create this blue box, which was membrane WebRTC object. And the whole definition of this object we need to provide the behavior of that object. And it's done with the callbacks mechanism, which we pass in the constructor. So let's start with the first callback. Just for a moment, that's plenty of code, so I will copy paste it here. And what we have is the onSend media event. So this callback gets called once once this blue box, the membrane WebRTC object, wants to send some media event to the server side. So what we do here, we simply push it via the channel. So probably it's quite easy to understand what happens. The other callback, it's much longer. However, do not here because generally the behavior described here is also quite easy. So this is on join success callback. Once we get accepted by the server, because the server can accept us or reject us when we try to join it as a client, we have to perform actually a couple of steps. First, from all our local streams, which are like the audio stream and the video stream, we need to put them inside the WebRTC object, all of these tracks, so that the WebRTC object can deal with the tracks we've put there. And we also need to add the video element for each of the peers inside of the room. Of course, we're using some predefined methods here, but there's nothing special about them since it's only dealing with the UI so like this add video element. Okay, here we go with the other method, the other callback, which is called onTrackReady. So as you can see, we have put our tracks, for instance, inside the WebRTC object, and once they become ready, this callback gets invoked. And what we do is that we are attaching that stream to the browser element, which is capable of displaying that media, so like the video or audio from the stream. And we have two other callbacks we're gonna implement, like on peer joint. So probably you can guess when this callback gets called, because it gets called when a new peer joins the server, and we have to be informed about that so that we can add the video element for the newly connected peer. So this is like what happens once some peer joins the server, and of course the corresponding callback on peer left, which gets called when a peer left. There are a couple of other callbacks described in the documentation of the membrane WebRTC class. However, we do not need them in our case, so we won't implement them. Okay, so as you probably remember, we had this communication here. However, right now, what we do is that we are simply passing the media events from the membrane WebRTC where they are generated via our room to the channel. But we also need to do it in the opposite direction. So we need the events sent from the server to be passed to the membrane WebRTC object. So we need to somehow fit that object with media events. And that's why we also need to handle a situation which might happen on a WebRTC channel, which is the situation in which we would receive some media event on the channel. And what we do, we call a receive media event function on the WebRTC object so that this media event can be transported to the WebRTC. So the constructor is right now ready. But as you could see, once I was connecting to the room, we also need to join that room, yes, because we're like clicking the connect button. And this, once we click the connect button, this method gets called, so the join method. And a really important thing to do here is to make our membrane WebRTC object rejoin the room, so provide a communication with the server, and we do it with the join methods, and we can pass some custom options like our display name to the server. So probably right now we are done with the JS part, and we can go to the Elixir part, because as I said, this is the findings application and our backend is of course in Elixir. So probably it will be more interesting according to the name of the meetup. So let's refer to our scheme, because right now we are somewhere here. So we have to provide this bidirectional communication between the channel and the room, so that we can push the events via the socket once we receive them from the room, as well as to send some events to the room when we receive them from the socket and from the client side. So of course, what we have here is a process which will deal with that stuff. And of course, we have some kind of initialization of this process. But the behavior, so the thing we need to define here is simply can be done with implementing two callbacks. So the first one here, we are sending media event to the room process once we receive them from the socket. So we are handling that media event and sending it to the room where we have our custom business logic. And the other way around, we do it with responding to a message. So once we receive the media event message, we simply push it through the socket. So that's it when it comes to the peer channel. And now probably we will have to deal with the most complicated part of the system, which is the room process, which describes how the server generally works. And of course, we will need to define some callbacks since it's like behavior driven. So let's start. Let's do it. Our video room is a gen server, and we need to provide the initialization of that gen server. And now probably you can see a large amount of code, but do not fear it, because it's almost only defining some options. And in really most cases, all you need to do is to simply copy them from the documentation. And of course, if you need to change them, you can do it and basing on that documentation. But like these three lists are simply options. What is important here is how we start the RTC engine, and we do it just over here. So we are starting and getting the process ID of the newly created RTC engine process, and we register ourselves, so our room process inside that RTC engine, so that the RTC engine will know to who to talk when he wants to send some media events to the client side, for instance. And of course, we are keeping that in our state all along with the peer channels map, because we have to have a way to where we have to know where to direct the messages from the room to a particular peer channel. Okay, so right now our initialization is done, and let's start implementing the callbacks. So maybe just for the beginning, let's handle the situation in which we are told to send a media event to the client side. So we are, well, this implementation here comes into parts, since we can receive such a request either to broadcast that message, so to send it to all peer channels which are currently held in our state, as we do here, or we can do it to a particular peer channel, so to a particular client. And we do it simply with plain like kernel send function. Once we are done with sending the media events, we can, okay, I haven't probably fulfilled the whole function, so give me a moment. Okay, right now we are ready. And now we're gonna handle some other messages which do not need to be transported to the server side. An example of such a message is the new peer message. So it's quite a big one, so I will try to describe it in details. But maybe it will be easier if I would refer to the scheme once again. So as I said before, the place where we hold the business logic is room process. And the idea is that once the client requests to join, the media event is sent from the membrane WebRTC, and of course it's transported via the socket to the server side. And we do not open that message anywhere here. We are simply feeding the RTC engine with that message. And RTC engine sends the room process a message, which is somehow the way to provide we can provide our custom logic in that way, because once we receive such a new peer message in the room, we can decide whether to accept or to reject the client who tries to connect. So we can, for example, create a room in which we would allow only 10 people in a particular room, and all other clients would be rejected. So let's go back to the code and see what I've pasted here. So as you can see by the logger message, we of course are accepting the peer. We do not reject. We are nice to the client who tries to connect, and we are creating the endpoint. So as you have seen on the scheme where I was describing the RTC engine, each browser has a corresponding WebRTC endpoint, and this is where we are creating the endpoint. So generally, we are passing a couple of options predefined in the initialization step, creating that endpoint, and then we make the engine accept the peer. As I said, we can also reject the peer in this place. And after that, we can add this endpoint to the engine, and starting from that point, our RTC engine would have one more WebRTC endpoint inside, which would start to receive the media from the browser, which would publish the tracks received from the browser, and some other endpoints could simply subscribe to that endpoint and start receiving the tracks and relaying them to other browsers. Okay, and following on the behavior implementation, we have another callback, which is our reaction once we receive the message that the peer has left. We are simply logging that fact. Of course, we could do some other stuff, but it's probably nothing more interesting to do here. And of course, even more important callback is the callback which defines our reaction once we receive the media event message. And what we do is we feed the RTC engine. So referring to the scheme, once we receive a media event message, we have to pass it to the RTC engine so that it can behave properly. Okay, so generally speaking, we have implemented a couple of callbacks, both on the client side and on the server side. And let's try to check whether it started working. So mix, and we are starting the server. Now the big moment has come. We will see what are results of our job here. Let me check. Okay, so let's try to connect. So the first peer connects, but it does not mean anything. Let's try to connect the other peer. And as you can see, we have the starting point result. So we can see each other. And just at the end, I'm not sure how much time left do I have. Do I have any time left?
Someone said 8 minutes. We can agree.
Okay, that's great, because I would like to show you what happened on the server side, because we have some logs, because we are using a logger, and we have tracked some information what happened within the server. So as you can see, once the first peer joined, it generally the server spawned the new room process, and this room process started a new RTC engine. So this happened once the first peer connected to the room. And of course, another peer has connected to the room, and the tracks started being relayed, so between the endpoints inside the server. So you can see that we have here like a VP8 track, which stands for some video codec, and the Opus track, which stands for audio codec. And it started transporting between the endpoints. And once the other peer joined, of course, he also started sending his media to the server, and among the endpoints, this media also started being relayed. So we can see this. And of course, we can, where is it? Oh, here we are. We can leave the channel, and probably we should be informed about it, or maybe we are not. Okay, but generally speaking, we are keeping track on what happens inside the server. Okay, so I would like to thank you for listening or for watching.